Hey, beautiful people, welcome back. This is part 2 of applying the 3 moments equation to the continuous beam we're dealing with. Let's go. So now, applying the 3 moments equation to support C, that is the interior support C. Let's go, guys. So, back to the question. So now, we're applying the 3 moments equation to support C. It will now mean that if we're applying and dealing specifically to support C, it means that support B and support D are the exterior supports. So, let's now write the 3 moments equation. Interior support C. So now, when we apply the 3 moments equation, so I'm trying to get the best. Okay. So when we apply the 3 moments equation to our interior support C, we're going to be having MB using the same steps above. That is ML over I plus 2MC. That is 10 over I plus 10 over I. Since the two lengths are equal, plus mg over I, which is equals to, remember in the 3 moments equation, we're having left here, we're having right here. So left to C was B. That's why we're having MB times LB, and LB is 10. So that's why we imputed 10. Similarly, we did this for the right. So now let's go to the right-hand side of the equation. That is, once again, since it's the same question we're dealing with, P is 0. So, but there's a uniformly distributed load, which is in the formula WL cube over 4I. Then we apply it to the left, which is 30 times 10 raised to the power 3 over 4I. We apply it to the right. 30 times 10 raised to the power 3 over 4I minus 6, 200 times 10 raised to the power 9 over 10 raised to the power 3. Now our settlement, yes. So delta left minus delta interior support over L of delta left. So it means that delta B minus delta C over L and B rather. So it will be having 0.05. You can check the values in the question. You see that it's tallies. 0.2 over 10 plus, similarly to the right also, delta R minus delta C over LR, which is 0.04 minus 0.02 over 10. So we'll be having 10 MB over I. We'll be having 2 MC. This question is straightforward. I would love to see questions like this in my exams. But now I wrote a question. I'm already skipping the steps. It's straightforward. So MD is 0. Remember I explained that for a beam, of course, when you're finding the moment, what is there for you to cut to find the moment? Nothing. So your moment is zero. Just know that your moment is zero. Maybe when we're solving, when we're analyzing for the bending moments, I would try to prove this. So 2mc 20 high. So minus 60 times 10 raised to power 3 over 4i. We combine the two terms. Minus 1200 times 10 raised to power 6. And we have 3 times 10 raised to power minus 3 plus 0.002. We have 10 MB over high plus 40 MC over high equals to minus 15 times 10 raised to power 3 over high minus 1200 times 10 raised to power 6. Combine the two of the terms, we have 5 times 10 raised to power minus 3 now we're having 10 MB over high plus 40 MC over high equals to minus 15 times 10 raised to power 3 over high minus 6 1, 2, 3 1, 2, 3. Now we're having, when you simplify it all, we'll be having 10 MB plus, so that is when you multiply everything by I, and you know your high is 7 times 10 raised to power minus 4. Minus 15 times 10 raised to power 3 minus 6, 1, 2, 3 1, 2, 3 times 7 times 10 is minus 4. We'll be having 10 MB plus 40 MC equals to, we'll be having minus 19200. We'll be having, dividing everything by the 10, we'll be having MB plus 4 MC equals to minus 1920. So guys, this is equation 2. So now earlier, we've gotten equation 1, and now we've gotten equation 2. So bringing the two equations, 4MB plus MC equals to minus 912. This was the first equation we got in the first video. This is the second equation equals we're getting now. Solving this simultaneously, we have MB to be minus 115.2 kilonewtons meters, and we have MC to be minus 451.2 kilonewton. Kilonewtons meter. So notice that the moments are negative. Relating this to the bending moment convention, that is what we use to solve our bending moments. When it's like this, these are all gain moments and they are negative moments. So what this means is that at our support, we'll be having these two. For this, at support B, we'll be having this. Support C will be having this direction of moment. That's what it means. And what this means is that instead of having in your, you did bending stresses, instead of having compression at the top and tension at the bottom, you'll be having tension at the top and compression at the bottom. So let's now compute for the member shear end forces. Let's split our beam. The first part. This is the support. Splitting the beam again. Support. Splitting the beam again. Yeah, just please chill, guys. You see what I'm doing now. So this is the support. Now, this is A, this is B, this is B, this is C, this is C, this is D. What we just did was that we splitted the beam. Let's go back to the top most part. Notice that this is how the structure is. But now, here is the splitted structure. Let's continue this in the next video, guys. Thank you. Once again, if you find this video helpful, or if you rather found the video helpful, please kindly like the video, kindly subscribe to the video so that more students can find this. Thank you, guys.